Lab 1 is about functions, and you can check page 40 to 50. On the textbook about this part. Okay, let's look at question 1. So question 1 gives us a quadratic function y equals x squared minus 2x minus 3, and together with this graph. So first part is about its domain. Domain is where this function is defined. Because it's a polynomial, right? Its domain is the whole real line. It can be defined everywhere. And the range is on which part the value of this function is defined, right? So if you look at this graph, the minimum value for y is -4, and the maximum is infinity, right? When x goes to infinity, y also goes to infinity. So the range is from -4 to positive infinity. And this bracket here means the -4 value can be achieved. And the parenthesis means you cannot achieve that value. And x-intercepts and y-intercepts are the location where the graph intersects the x-axis and the y-axis. So if you look at the graph here, the quadratic function intersects with the x-axis at x equals -1 and +3. And the y-intercepts, the y-intercept is where this graph intersects the y-axis, and this graph intersects at this point, right? So -3. So the x-intercepts are -1 and 3, and the y-intercepts is -3. So that's the answer. And state how you can find this function's characteristics using the function's equations. Yes. So another way to get all these answers is by the equation of this function instead of using the graph. So let's look at the equation. So the first one is since the function y equals x squared minus 2x minus 3 is a polynomial, so the domain is the whole real line from -infinity to positive infinity. The second one is about the range. So if you look at this function, and we can find where it takes its minimum value, right? So to do this, let's write y equals x squared minus 2x minus 3 equals x. Let's complete the square. X squared minus 2x plus 1 and minus 1 and minus 3. So you plus 1 and minus 1, like you simply add 0 to it, so nothing is changed. But the equality holds. And this part is a complete square, so we get x minus 1 squared minus 4. So you have something squared, which is always a non-negative number. A non-negative number minus 4, so this is greater or equals to -4, right? So the minimum number is -4. And when x goes to infinity, is clearly this value goes to infinity. So the range is from -4 to positive infinity. And you can achieve -4 when x equals 1, right? When x equals 1, x minus 1 is 0. Okay, that's part 2 and part 3. So to get x-intercept, we want to make y equals 0. So y equals 0 means x squared minus 2x minus 3 equals 0. So you take the roots right? The roots are, so as we have said, this expression is equivalent to x minus 1 squared minus 4 equals 0. So this tells us x minus 1 equals plus minus square root of 4. So x equals 1 plus minus 2. So this gives us two numbers. One is negative 1, the other one is 3. So these two are the x-intercepts. And the last one, the last one is y-intercept. Y-intercept is where x equals 0. So when x equals 0, you plug into this, you substitute into this expression, you get y equals 0 squared minus 2 times 0 negative minus 3, so this is negative 3. So the y-intercept is negative 3. Okay, that's question 1. And question 2 is, so this function is given completely by this graph, right? There is no algebraic expression of it. So you just read off this graph, and that's the second question. So let's read the graph. So when x equals negative 1, so it's this point, and at this point, as you can see, the fx value is 4, right? So here we get a 4. And similarly, when x equals 2, you get this point, and you look at the fx value, this is negative 1. When you look at 4, you get a little circle here. The little circle means the function is not defined here, so this is undefined. So question 4 is negative 2 times f1. So the first step is to get what the number is for f1. So you look at what x equals 1, you look up, and here you can see that the value for when x equals 1, fx equals 3. So this in turn is negative 2 times 3, which is negative 6. Okay. So question 3, sketch the graph of this function. So this function is piecewisely defined, and each part is a line in itself. So we just need to evaluate at several points. So a good choice would be x equals 4, and when x equals 4, I get, so for this part, for the first part, for smaller than 4, I get 0, right? f4 equals 0. And when x equals 0, which is smaller than 4, I get f0 equals, you plug into the first expression, you get 8, right? So you draw these 2 points, 4, 0, and 0, 8. So basically, you get this point. This is 0 and 8. This point is 4 and 0. And you just connect these 2 points by this line, by this ray. And when x greater than 4, when you plug in 4 to this expression, to the second expression, you also get 0. So it's 4, 0 is also a point for the second line. And you can also check, for example, when x equals 8. So this is 8 times 1/2, which is 4 minus 2. So that means at x equals 8, we get, 5, 6, 7, 8. At x equals 8, we get f, give me a second, get f at 8 equals 2. Okay, so that means 5, 6, 7, 8. At this point, we get 2 here, right? So basically, you need to connect these 2 points to get a line, right? And these 2 line segments together gives us the graph, right? Basically, that's how you solve this third question. And the fourth question is about the revenue and profit. So a clothing company wants to sell soccer jerseys to school athletes, soccer athletes. So we have the cost function cx given like here. The function is a quadratic function given to us. And also another information is each jersey is $100. So the first question is the revenue of this function, revenue function of this company, right? So if you only consider the revenue, so this 100 times the number of the jerseys you sell, right? So the revenue should be this function, right? 100 times x. And the profit is the revenue minus the cost, right? So revenue is this function, cost is this function given here. So this one minus this one, you got this function, right? And how many jerseys, the third question, how many jerseys must they sell to make a profit? If you set this profit function equals 0, you get x equals 31.5. So this is a quadratic function, and with the highest order one with a negative coefficient. So it looks like this, right? The function looks like this. The first 0, the first x-intercept is at here. This is 31.5. So when x greater than 31.5, the profit becomes positive, right? And this is about 800. So x is smaller than 500. So our function is defined here, right? So you have to sell at least 32 jerseys to make a profit. If you sell 31, it's smaller than 31.5, so the profit is negative, right? As you can read off this graph here. So the fifth question is about a linear model of functions, okay? And it says this graph is the credit of in dollars of a phone depend on the calling time. So the dependence is a linear function, and with a slope of negative 0.16. So what's the meaning of a slope? The slope is like it means for each minute the cost is this much, right? So now you already know after 28 minutes the cost is 28.92, and the question is what is the cost at 15 minutes? So now with all the information given, we have this relation, right, in our mind. So where does this relation come from? So because after 15 minutes, that's the cost here. And from 15 minutes to 28 minutes, like how many minutes have already passed, right? Oh, sorry. This number is 8 minus 15, this is 13, right? 13 minutes have passed from 15 to 28, right? 13 minutes have passed. Each minute you cost this much money, so after 28 minutes the cost will be the cost at 15 minutes minus 0.16 times 13 minutes, right? So that's the relation, and you just plug in the numbers. So this is 28.9 equals C15, that's something we want, minus so add this number on both sides, we get so that's the answer, right? Okay, the last question. So we get a linear equation. This linear equation is about the value of a car and depend on the time in value over time. So find the v and t intercept. So the v intercept is where the t equals 0. Right? You said t equals 0 in this expression, you get v equals 15 thousandths. And the t intercept is where the value v equals 0. And you said v equals 0, you get t equals 15,000 over 25. Over 25 hundredths, right? So this should be 6. I think so. And so the v-intercept is where the t equals 0. This means the value of a brand new car, right? And t-intercept is where the value becomes 0. That means this is the time where the car become worthless, become invaluable, right? That's how you interpret this intercept in this question. Okay, that's all about these 6 questions, and that's lab 1. Okay.